So we have learned that buoyant force is nothing but apparent loss of weight of a substance or the weight of the displaced water. Now see these three diagrams. Here I wanted to tell you that when the body sink, when the body float. See the first condition, the body inside the water. Now the weight acting downwards, buoyant force acting upwards. When the body inside the water, simply you can say that the body sinks. Yes, correct. But what is the condition? The condition is weight of the body is greater than buoyant force. That's why body sinks. Coming to here. Here weight of the body equal to buoyant force. Therefore the body floats. It floats. Now coming to here. Here also body floats. But here what happened? Weight of the body is less than buoyant force. That's why the body come onto the surface of the water. So these are the three conditions to understand that when the body sinks, when the body floats based on weight and buoyant force. One fine day, a person went to a kingdom and the king said that he has to measure the weight of his crown, and nobody understood how to measure the weight of his crown. And king told that if you don't tell the answer by end of this day, then you will be hanged. Then that person went to home and he started thinking that how to find the weight of the crown. So what he done? So he wanted to bath. Archimedes went into his bathroom and he get into the water bath which is filled with the water till the surface. He observed that as soon as he entered in the water bath, the water is spilled out. Then immediately got the idea and he ran into the roads of his kingdom and shouted that Eureka, Eureka, means I got it. Then what he understand that the amount of water spill out from the water bath is called displaced water, and the displaced water weight is equal to the weight of him. So immediately he understand that to find the weight of the crown, he has to put the crown into the water and he has to find the weight of the displaced water. So what is Archimedes principle now? Archimedes principle says that any substance fully or partially immersed in a liquid, then its loss of weight is equal to buoyant force or weight of displaced liquid. So that is the Archimedes principle. Fully or partially immersed. You can immerse partially, you can immerse fully inside in a liquid. Then its loss of weight is equals to buoyant force, the buoyant force acting upward, or the weight of displaced liquid. When you are traveling in a bus or in the trains, or when you are driving a bike, motorbike, suddenly you want to stop those vehicles. What do? You apply the brakes. When you apply the brakes, immediately the big sized body stops. If you observe how you are applying the brake, you are keeping your foot on the braking pedal and applying very little force on the braking pedal. Immediately the big sized car, the big sized lorry or the truck stops. How it is possible? Applying little force on the brake pedal, how could you stop a big sized body? And the magic behind that is Pascal's law. Pascal explained how to make those type of brakes, and those brakes are called hydraulic brakes. To understand what is hydraulic brake, let us know what is Pascal law. Pascal told that the pressure acting on a point in a liquid is distributed evenly in all directions at a depth. This is what Pascal's law. At a depth, see, h is the depth. This is the point. On the point, the pressure what he applied, it is same in all the directions. This is what Pascal told. How would you examine whether Pascal is right or wrong? So Pascal is saying that at a given depth, the pressure is constant. If the depth changes, pressure also changes. Let me show you how to do the experiment at home. Take a plastic bottle, water bottle, fill the bottle with the water and cover with the cap. Now this is the water. Now make a hole here, make a hole here, make a hole here. This is the hole A, hole B, hole C. Using your safety pin, just pierce inside at three different depths. Now what happened? As soon as you make a hole, immediately the water falls. Water falls on the ground. And if you observe, this is the ground. If you observe, which hole has shown the falling of water having more distance from the bottle? Obviously, the point C. Why? Because point C has greater depth than point B and point A. So, when the depth increases, the pressure acting at that point also increases. So, at this point C, more pressure is applied. That's why the flow of water covering larger distance than A. So, this simply says that Pascal law is true. Pascal's law has got so many applications in the industry. The hydraulic brakes, hydraulic lift, hydraulic press, all those are the best examples and applications of Pascal's law. Earlier told that if you supply small force in the brake pedal, you are stopping the big sized vehicle. How it is possible? It is only because of that. Even the force is small, but the pressure distribution in the vehicle is equal and same in all the directions. And the same pressure goes to each and every part of the brake pedal to brake discs and applies large amount of force on the wheels. And so that wheels are affected by the brakes and they will be stopped. Now let me explain you more detail about this Pascal's law using this application, hydraulic lifts. Hydraulic lifts means if you want to lift a heavy body with less amount of force application, then we use hydraulic lift. If you go to any car workshops, there you can see the car mechanic put the car on a steel cylindrical platform and he press a button. Then the automatically the cylinder rises up, so the car also rises up. Sometimes he uses a valve, he uses a handlebar, and that handlebar he rotates slowly. Automatically the big sized car rises up. So he's applying very small force, but their larger force is multiplied and lifting the car up. So that is the example of hydraulic lift. So how it happens? I will tell you mathematically. So this is a system generally used for hydraulic lifts. Here is the platform where you have your car is placed, U-shaped tube, and here this U-shaped tube is filled with liquid. You can fill with liquid or you can fill with air also, no problem. Say you fill with liquid. Here this platform has area A1, this platform has area A2. By the diagram you can understand that A2 is greater than A1. This area is more than this one. Now here you applied a small force F1. Small force F1. Whenever the small force F1 is applied, there is a force acting on the platform which is F2. in upward direction so that the car lifts up. How it is possible? You know that force by area is a pressure. So whenever a small force applied on this platform, the pressure is applied on the fluid or the liquid